back to linear algebra. Let's begin with Anki. Yesterday I did shortened session, so I didn't record a video, but wow, we got 12 flashcards. Okay, what is the standard matrix for a reflection about the y-axis in R2? -1, 0, 0, 1. What does it take? What is the notation? Transformation A, Rn to Rm denotes matrix transformation from Rn to Rm, and then the whole thing with W equals AX. What is the standard matrix for a reflection about the x-axis in R2? 1, 0, 0, -1. What are the leading variables in a linear system? Leading variables are variables in a linear system that are associated with the leading ones in the reduced row echelon forms of the matrix. Variables associated with the leading ones in the row echelon forms. Row echelon form, reduced echelon. Row echelon forms. All right, we're gonna say fine, but reduced row echelon forms 1, and then there's multiple row echelon forms. What is a transformation from Rn to Rm? It's a basically a rule that associates a vector in Rm with each vector in Rn. A rule that associates a unique vector in Rm with each vector in Rn. Okay, good. How might you rewrite the expression Ta parenthesis K1 U1 plus K2 U2 plus ... plus Kr Ur as a linear combination? K1 Ta U1 plus K2 times transformation A of U2 plus ... plus Kr times transformation A of Ur. State necessary and sufficient conditions for transformation Rn to Rm to be a matrix transformation. Homogeneity and additivity properties must hold for all vectors in Rn. What is the standard matrix for a reflection about the line y equals x and R2? 0, 1, 1, 0. What is an elementary matrix? An elementary matrix, that is a matrix that essentially it's an identity matrix plus one elementary row operation. So a matrix that can be turned into an identity matrix with one elementary row operation. Matrix that can be obtained from an identity matrix performing a single elementary row operation. Yep, same thing. What conclusion can you reach if the transformation A of x equals the transformation B of x for every vector in x, vector x in Rn, A equals B? What is a matrix transformation? It's a transformation from Rn to Rm in which the whole thing with W equals A times X, where A is the standard matrix, W and X are vectors, column vectors. All right. Stated procedure for finding the standard matrix A of a linear transformation. First, we find the image vectors of the transformation of the standard basis vectors in Rn, and then you partition them together so that they're the columns, sequential columns of the standard matrix. All right, that's actually it. Okay, then I'm gonna grade. Actually, I don't think we have anything to grade. I think we're working on the proof was the last thing we're working on, so I'm gonna continue and finish that proof today and see if I can get past that. So talk to you in a bit. I finished the second part of this proof, basically showing if A and B commute, then transformation A and transformation B commutes. So here's what I had. If A and B commute, then AB equals BA by definition. Given theorem 1.9 for 1, TAOTB equals TAB. By definition of matrix transformation, TA can be represented as W equals AX. If TA can be represented as W equals TAX, then TAB can be represented as W equals ABX. If AB equals BA, then W equals AB, X equals BAX. If W equals AB, X equals BAX, then TAB equals TBA. If TAB equals TBA, then TAOTB equals TBOTA. If TAOTB equals TBOTA, then TA and TB commute. Then we did a little review problem from 1.4. It's true or false. If A is invertible, then so is the transformation of A, and I said true. Invertible, transformation. I remember seeing this. I remember this. The inverse of the transformation is equal to the transformation of the inverse. The transformation of the inverse is equal to the inverse of the transformation. Yeah. So I think that's true, and definitely you can just think about a 2 by 2 matrix and know that AD minus BC cannot be equal to 0 for it to be invertible, and the transpose does not change A or D or B or C final value. So then we did 2 true or falses from 1.9. The first one was basically saying if basically 2 transformations are both operators in the same Rn, both operators in Rn, then they commute, essentially. They didn't say commute directly, but they said the transformation B of the transformation A and the transformation A of transformation B equal each other. No, and then I just give a counterexample of orthogonal projection onto the line at y equals x, and then a reflection over the x-axis, both starting at this point, will result in one point ends up being here, and the other point ends up being here. So they're not the same endpoints. And then the second true or false is basically if 2 compositions or 2 transformations are composed and they're both reflections, then the result is another reflection operator. And I said no, because basically if you have 2 reflections that are about the same line or axis, then the composition of their reflections will be the identity matrix. Nothing will happen. If you reflect over the x-axis twice, you're going to end up in the same spot. So that's it for today. Talk to you tomorrow. See you.